Hello, what's up there, YouTube fam? Today we're going to solve the first medium level problem in LeetCode, add two numbers. And what's special about this video is that I'm going to code in C language. Previously, I used to code in Python, and that kind of was easy. And I had a long break in LeetCode because college has started, and then there was not much of a time to sit down and practice LeetCode. So in the timeline of my semester, we've been doing so many programs in C, and I kind of got used to C. So I really wanted to start LeetCode again from the beginning in C language. So here I am today. So we will be going ahead with solving the question add two numbers. So I'll quickly read out the question. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. So basically, we have a number, right? So in this case, it's actually 342. The linked list is actually in the reverse order. So we're given two non-negative numbers in the form of linked list, and we are supposed to return a linked list as well, which will be the in the form of the linked list will represent the sum of these two non-negative numbers again in the reverse order. So typically you would have to take 342, add it to 464, 465, and you would get 807. But your output should be ahead. So your output should, at the end of the day, be 708 and not 807. So it took quite a lot of time for me to solve this in C because uh, quite a lot in the sense more than about 2.5 hours because I am relatively new to solving problems in pointers. So I will I did take a lot of time, but nonetheless, I think what I've done is kind of interesting. Having a little basic knowledge of programming, this is what I was able to do. But I was able to pass only around 31 test cases when I submitted the question. Uh, when I first submitted my code. Okay, it seems to be like there's an error. Oh, stop. List node star h2. Okay, that should do the work. This kind of passed three of the default test cases, and then when I came across this test case, my code did not give the right output. So when I submitted it, so this is where my code failed. So and then I had to go to ChatGPT and ask it to tell me where I'm going wrong. So then it actually generated a code which actually works much better than what mine is. It was also able to identify what exactly my code was doing, which is not surprising at this point. ChatGPT has got very uh, advanced, and it is able to understand code and say it in human terms. Abstract the idea without even having to print the question. So I didn't even have to ask. I didn't have to take this question and paste there. It was able to understand from the code itself. So that means my code is not bad, honestly. If ChatGPT was able to understand that what I was trying to do is literally uh, is literally what the question is also about, So that means I'm not a bad programmer. In that way, I feel really glad. Alright, so I'll quickly explain what my code is. I have copied it over here because it's much better to understand. So before going any further, my I'll give a quick diagram of what my idea was. So let me open. So we had two inputs, right? 254, no, 243 and 560. 243 and 564. Was it? That's it. So my idea was to use a head, let's say h1, right? And use power of 10 starting from power 0. So power is equal to 0 in the first place. So then I will take a sum for h1, right? Sum for h1 or the first first list. So what I'm going to do, I'm going to say sum plus is equal to this digit multiplied by power of 10, right? I mean it's called pub, right? In C, the pub function from math.h library. So 10 and then power plus plus. So what this basically does is, and initially this was 0. So to 0 in the first place, 0 plus is equal to 2 into power of 10 raised to 0 is 1. Then power is increased, right? So after this, power is increased, so it's 1. So we'll go to the next digit. H1 will point to 4. So sum will be 2 plus is equal to 4 into 10 raised to 1 is 10. So that will make it 42, and power will increase again by 1. So power will be 2. And finally, when h1 is pointing to this, we say 42 plus is equal to 3 into 10 raised to 2, which is 100. So that will be 342. So that way you are able to take each digit and make the corresponding number out of it. The same I'll use h2 for this, right? Pointing using sum similar to what I've done for the first number, and then I'll get 465. Now I'll take the sum of this, so that is 7, 0, carries, and 8. So now this is 807. Okay, but we'd have to give a list which says 7, 0, and 8. So when I was first writing the code yesterday in the night, I did write a function which takes makes head, like you make a node, right, and you use a head pointer. So you make a new node, and then you say this points to this and move head here, and this points to this and move head here. So I did not realize that while I'm doing that, at the end my head will be pointing here, and my list will actually be 807 instead of 708. And then I had to struggle a little bit, and then finally I the idea flashed into my mind. At first, what we'll do, if head is null, we'll create and point head to this, and then we'll use a temporary pointer also initialized, and then when you create a new node, we'll say temps link is this, and then we'll move temp to here. And the same, so what we do again is we create 8 and we say temps link is this, and we move temp from here to here. And then finally, we'll get rid of temp, we'll get rid of temp and we'll return head. So and then finally it will be 708. This was basically what this code is doing. This is basically what this code is doing, and that's precisely why uh, I was able to get the right output for case 1, case 2, and case 3. But when it came to case 4, I utterly failed because the number of digits over here were 10, and then after reversing it and adding 9 to it, my result got something very weird like this. It got very weird like this, and I was not able to get the right output. So before going to the correct code, I shall be showing you my code. So whatever I've explained on my whiteboard over here, I have coded them. I have coded that over here. So let me quickly go ahead and erase all this, and we'll do it from the beginning. It's silly to use backspace at this point. Okay, so first thing we will be using is a head node. So we'll use head and we'll equate it to null, and then we'll have to, I didn't want to take L1, so I'm using a temporary node called H1, right, which will be equal to L1, and the struct list node H2 is equal to L2. So now I will use variables. So R1 is equal to 0, R2 is equal to 0, and R3 is also equal to 0. So now R1 is actually going to get the number for the first list, R2 for the second list, and R3 is going to take the sum of these two, right? It's going to add these two. So how do we get the first one? So we'll make a temporary variable for power of 10, and okay, let me name it as power of 10. All right, power of 10. So now we'll say while h1 does not equal to null, we're going to say r1 plus is equal to h1 var, right, into power of 10 comma pot plus plus. So what this will do is take this value, power of 10, do it, and then increase power of 10. I think all these will be using stack in the memory, right? Uh, that is a different tangent. Let's forget about that. And then we will say h1 is equal to h1's val. Now the same thing we'll do with h2, but since power of 10 will have increased to 3, we'll have to change it back to 0 before proceeding any further. So R2 plus is equal to H2 val into power of 10 comma TOT plus plus. With that, we are officially done with using TOT is equal to H1 next. H1's next. Okay, yeah, I've totally forgotten. So this is what the structure of a linear of the list node is int val struct list node star next. Okay, now what we're going to do is we're going to say R3 is equal to R1 plus R2. So that will give us the sum. Now I'm going to make use of a temporary variable struct list node star temp is equal to, I mean we can equate it to null, not a problem. Okay, so now we're going to use, while R3 does not equal to 0, we're going to say int val u is equal to R3 percentage 10. So that way you're going to get the last digit, right? So the R3 will contain 807. So when you get the remainder by dividing it by 10, you'll get 7. So our value will contain 7. And then we'll change R3, and then we'll change R3 by dividing it by 10. So now 807 will become 80. Once we've done that, we'll see if head double equal to null. So that means we're creating the first node. If the head is null, we're going to say struct list node star new node. New node is equal to struct list node star malloc size of struct list node. Okay, so that way we have created a new node. We'll say new node is equal to new node val is equal to value, and we'll say new node next is equal to null, and we'll say head is equal to new node. So that way what we're doing is we're creating two, right? We're creating two, and we're saying, okay, we're not creating two, we're actually creating 7, right? We're creating 7, and we'll say this is pointing to null, and head is pointing to this. If that is not the case, that is, if the head is not pointing to null, in that case what we're going to do is we're going to say struct list node. Again, I should quickly just copy this over here. Remember, I also said we'd have to point to this by using a temp. So since I already created temp here, we're going to say temp is equal to new node. So temp is also pointing to same node. Now what we're going to do is, once you created this node, we'll say temps next is equal to the node. So we'll say it's equal to new node, and we'll add the value new node ka val is equal to value, and then we say new node next is equal to null, and we'll say temp is equal to new node. So now what's happening, we are creating a node, right? So we're taking 0 into this, and what we're going to do is we're going to say this, instead of pointing to null, will be pointing to this. Therefore we are successfully able to make this kind of link. So once we've done that, we're going to say temp is not pointing this anymore, instead it is pointing to this. We could have done it after adding the values as well. That is, these two lines could have been after assigning the value to val and saying next is equal to null. That is basically completing the node and then telling to add. So that's absolutely fine. Give me 1 second. Are you able to see the code well? Yeah. Okay. So that way we're going to get head. So now just to be sure of what is happening exactly, we say struct. We take another new pointer, struct pointer. Let's say whatever h. Let it be equal to head. So we'll say while h is not equal to null. Let's say printf percentage d, and we'll say h is val, right? And we'll say h is equal to h is next, and then finally we return head. Before that we have to free temp, so we'll free temp. So when you run this, oh, by the way, that will not solve the zero list containing zero. Oh, what is this? Some kind of error. Let me see. What is wrong? I don't understand. Heap after use, heap use after free at address. Okay, let me do one thing. I'm not going to free temp. We'd have to actually make it null, I guess. Let's run this now. Oh yeah, it's working. It is not working in the case of this, so that's why we had to add this simple 2 lines. If supposedly the list contains, just L1, I mean, if the list contains 0 in both the lists, then you just return the list, right? It's like an edge case. You don't have to work on the list. It's just waste of time. So when you run it, it is able to solve all the three cases. And then there was the problem with this. Somehow, when adding 9 to this number, it is cutting off. I don't know. I'm not really sure what is happening behind in the memory. I'm getting a strange -9, -3, -6, completely strange digits, non-negative numbers, non-negative digits. Sorry, negative digits. I mean, completely, completely unpredictable, right? That is for my knowledge. I don't understand what's really happening in the memory. So then I had to go to ChatGPT and I just pasted my code and I asked that when I'm giving a list one input as this and list two input as this, I'm not able to get the right output. So it was able to identify by saying, the issue with the code is that it tries to handle the addition by converting them into integers, performing the addition, and then converting the result back to a true linked list. This approach can lead to issues with integer overflow and loss of precision for large numbers, which seems to be the case in the input mentioned. Exactly. So when the number became too large, there is loss of precision because I was getting negative numbers, negative digits on summing 9 with uh, whatever. How many ever nines are there? 9 nines and then 1 1. So that should actually give me 1 followed by 10 zeros, right? 1 followed by 10 zeros. But I'm getting a string. No, it's not a string. I'm getting random negative digits only. So then ChatGPT generated this code, which seems to have been working against this. It seems to be working. Okay, let me control A and paste this. And when you run, it is able to do case 4. So let's quickly take a look at what this is doing. So it's creating a dummy node, right? A dummy node is usually just not containing any data. This is a dummy node, right? So it is used to connect to the first element of a node, similar to what I used, but I directly started with taking the digit. So here it is making use of a dummy node, and it's using another pointer called current and equating it to dummy. So current is pointing to dummy. Okay. So int carry is equal to 0. Now let's go to this side of the board. Let's select these two. Now, how do you select? Oh, okay, just drag down here. I just drag this whole thing. Okay, that is making. So then we're saying carry is equal to 0. So what exactly is happening in this code generated by ChatGPT is that it is adding every digit, like let's say 243 and 564. 5, 6 and 4. So what it is doing is taking these two digits, adding them, right, and seeing if there's any carry. That is, let's say in this case 6 and 4, that will give you a carry of 1, right? So that will be added later to this, and then 7, 3, 10, sorry, 4, 3, 7, 7 plus 1 is 7 plus 1 will give you 8. So it is on a higher level. This is what it's doing. It is taking individual sum of both the lists. It is taking sum of both the lists, sum of digits of both the lists, and then using a carry. So we're saying carry is equal to 0, while L1 does not equal to null, L2 does not equal to null, carry does not equal to 0. And the logical operators we're using here is OR. So that means that only when all these three conditions are false, only then the while loop will quit. Otherwise, the while loop will keep running. So since L1 is not null, L2 is also not null, and carry is apparently null, it doesn't really matter, because even if one of these cases is true, the while loop will run. So we go inside the loop and we say sum is equal to carry. So it's creating a local variable called sum, and it's equating it to call, and it's equating it to carry. So then we're saying if L1 does not equal to null, sum plus is equal to this. So it's taking sum is equal to 5, sorry 2, right? And then it's saying 2 plus is equal to 5. So that way we're getting sum as equal to 7. And then what we're going to do is going to say carry is equal to sum by 10. So that way we'll get if there is any carry. So but 7 by 10 will give you 0 since there's no carry. So in the beginning the sum will be equated to 0 again. When then we're creating a node equating it to some percentage 10, that is only the last digit, and we're saying new node next is equal to null. Okay, So let me just quickly take take. Okay, I'll draw the whole diagram starting from here. So we have a dummy node and we have current on it, right? So now what happened? We created a node and we put 7 into this and said this is null. Okay, and then we're saying its link, current's link, sorry, current's next is equal to new node. So then we are creating a link to that, and then we're moving current from here to here. So what happens next is that again L1 and L2 are not null and carry is apparently 0 and it really doesn't matter. So sum is equal to 0 now. Then what happens? We have 4, right? So will be 0 plus is equal to 4, implying sum will be equal to 4. And then sum is equal to 4 and we'll take this. So we'll say 4 plus is equal to 6. That will give us a sum of 10. That's 4, this is 10. Now you see there is 0 and 1. It's a 2-digit number. In this case, what we're going to do after this is we're going to say carry is equal to sum divided by 10. What is sum divided by 10? 1. So carry will give you 1. So carry will take the number in the tens digit place, tens place. Okay, that is what goes into carry. Then we're creating a new node and we're saying 10 percentage 10, remainder will be 0. So 0 will be added here. And we're saying this is null and we're saying next, current next is equal to this. And so null will be erased from here. And we're saying move current to this. And the same thing will be done for the next number. You'll have 8. This is null. So null will disappear. And then finally what we're going to do is we're going to move dummy, right? So we're going to, no, we're not moving dummy, we're making another pointer called result. We're making another pointer called result, point it to next of dummy, and then we're freeing dummy. And then we're freeing dummy and returning the result. That way, it is able to solve even this by taking the carry forward. So in my case, when the number became too large, there was an overflow of integers and I lost the sum due to some precision. In this case, we are directly adding and creating the node at the same time, which is making both the process much easier and also getting the accurate result. So that is it for this video. I hope you've taken away something really useful. If you really like the video, make sure you click the like button and also subscribe if you're completely new to the channel. I'll be uploading more videos uh, while I'm coding in C in LeetCode. This has been very interesting. Thank you so much for watching.